For this question, we have to graph a cosine function with several different transformations. But first, let's take a quick glance at the steps we need to take to do so. Remember, the first thing to do is to rewrite our equation into general form. We have to make a parentheses occur inside the parentheses. So what I do is I pull out a 3. If you don't do this step, it's very easy to get the phase shift wrong. You might think it's 12 pi rather than 4 pi, so always be aware, create a parentheses inside the parentheses by factoring out a term. Okay, then for step 1, we know that the amplitude is 1, b is equal to 3, the horizontal shift is 4 pi, and the vertical shift is positive 2. On to step 2. Step 2, our goal is to find the period. Remember, we can calculate the period by taking 2 pi and dividing it by the absolute value of b. Here, this tells us that the period is 2 pi over 3. This means to get to our ending point from our starting point, it'll take a distance of 2 pi over 3 along the x-axis. Next, we have to calculate the period over 4, or the interval between each critical point. If the period is 2 pi over 3, then 2 pi over 3 divided by 4 is pi over 6. Notice how we had to use keep, change, flip in order to solve this. This is common practice for these types of questions, so be ready to do it. Step 3, our goal is to find the starting point of our function. Normally, cosine's starting point is at 0, 1. This is because cosine of 0 degrees is equal to 1. We can even use the unit circle to help us see this. However, our function has a phase shift and a vertical shift. Because our function has a vertical shift of 2, it takes the initial y-coordinate and increases it by 2 units. So before, our starting point was at 0, 1. Now our starting point is at 0, 3. Now let's consider the horizontal shift. We have a horizontal shift of 4 pi. Since there was a minus sign in front of 4 pi, it indicates that there's a horizontal shift to the right. This means it takes our starting x-coordinate and moves it to the right by 4 pi units. So our initial coordinate was 0. 0 plus 4 pi is 4 pi. Therefore, our new starting point for this function is 4 pi, 3. Next, our goal is to find the 5 critical points. The first one is easy, it's just our starting point. So its x-coordinate is 4 pi and its y-coordinate is 3. Now what we're going to do is find the x-coordinates of all the remaining critical points first. So what we're going to do is we're going to take the x-coordinate of the initial point, which was 4 pi, and keep adding the interval to it. Do you guys remember what the interval was? It was the period over 4, so in our case, pi over 6. To find the x-coordinate of each consecutive critical point, just keep adding another pi over 6 to it. So the second critical point's x-coordinate is 4 pi plus pi over 6. The third one is 4 pi plus pi over 6 plus pi over 6. The fourth critical point is 4 pi plus 3 pi over 6's. And the fifth critical point's x-coordinate is 4 pi plus 4 pi over 6's. There's a lot of common denominators and reducing and simplifying here, but it's okay. I have faith you guys can do that. So if we go down the list, our x-coordinates are 4 pi, 25 pi over 6, 13 pi over 3, 9 pi over 2, and 14 pi over 3. Now how do we find the y-coordinates? All we're going to do is take these x-coordinates and plug it into our original function. Remember, at this point, it's critical that you know all the values for the unit circle. If you do not know the unit circle and its values, you won't get further than this point. So here we go. We find out that the y-coordinates are 3, 2, 1, 2, and 3 respectively. So therefore, we know that the 5 critical points are 4 pi, 3, 25 pi over 6, 2, 13 pi over 3, 1, 9 pi over 2, 2, and 14 pi over 3, 3. So all we have to do now is plot these points and then connect the dots. And there we have our answer.